In this video, we'll walk through the process of designing a real-world example of an industrial gear. Hello, I'm Milad, and I'm back with another AutoCAD tutorial. I've provided the full specifications of the gear we're going to design with all the details. We'll be using AutoCAD 2026 for this project. Alright, let's get started. First, I'll open the units dialog and set the measurement unit to millimeters, since the entire design will be done in millimeters. In this tutorial, I need to draw 3 circles. The first circle is drawn using the circle command, with its center at point 0, 0. This is the base circle for the root of the gear tooth. Its diameter is 22.5 millimeters. Next, I draw a larger circle with a radius of 12.5 millimeters. This one represents the pitch circle of the gear and shares the same center as the first. Then, I draw a third and larger circle, which defines the outer diameter of the gear, with a radius of 13.5 millimeters, again using the circle command. Now it's time to design a single tooth. I'll first create the shape of one tooth outside the main working area. To begin, I use the line command, a basic tool in AutoCAD, to draw a few guidelines. The overall height of the tooth is 2.25 millimeters. From the pitch circle to the bottom of the tooth, it's about 1.25 millimeters. And from the pitch circle to the tip, it's about 1 millimeter. The width at the base of the tooth is 2 millimeters, while the thickness at the pitch circle is roughly 1.571 millimeter. You need to be precise when drawing this part. As shown, I use both the line and scale commands to get it right. The tip width of the tooth is 1.2 millimeter, which means 0.6 millimeter on each side. Next, I use the spline command to draw the sides of the tooth. I rely on the guidelines to help me shape it accurately. I then delete the guideline that defines the pitch circle boundary, and use the join command to combine the remaining segments into one unified shape for easier movement. Now, I use the move command to bring the tooth shape into position within the gear circles. With a simple drag, it's easily placed. Then, I apply the explode command to break the tooth back into individual components. Using the trim command, which is extremely useful, I delete any parts that are outside the outer gear circle, as well as the internal guidelines inside the gear. To connect the bottom of the tooth to the inner base circle, I use the line command to fill any gaps. If needed, I use the extend command to ensure the tooth properly reaches the inner circle, making sure it connects accurately. Now that the 2 outer circles are no longer needed, I delete them. I select all the parts of the tooth and use the join command again to form one solid shape. Using Array Polar, I copy the tooth around the centre of the gear. Since the actual model has 25 teeth, I set the number accordingly. Next, I remove all extra segments with the trim command again, a very helpful tool here. Because I used Array Polar, the copied shapes are grouped as one object. To edit them individually, I apply the Explode command again. Once exploded, I select all the segments and use Join again to unify the full gear profile. After it's fully joined, I use the Extrude command to give the gear its thickness, which is 12 mm. I switch the visual style to conceptual or shaded for better visualization. Now I'll create the center hole, which is where the shaft will be placed. This hole has a diameter of 8 mm, which I create using the circle command. Then I extrude this circle by 12 mm, the full thickness of the gear. To subtract this inner cylinder from the gear, I use the Subtract command, which creates the shaft hole. To round off the sharp edges of the hole, I use Fillet Edge, and set the radius to 0.5 mm. This rounding is applied to both sides of the shaft hole. And now the gear is complete, just as you can see here. Be sure to follow my page for more practical and detailed tutorials.